So thank you all for coming this afternoon. It's my pleasure to welcome this afternoon Randy Pausch. I've known Randy for a considerable period, since he was a mere callow youth as a student. He had a degree program here that involved hardcore programming systems. Then he went off to the University of Virginia, where he found his true calling, which is finding ways to make it possible for real people, that is not like us, but real people who live out there in the world, to deal reasonably with computers. It's been largely in the area of user interfaces and graphics. He's done a wide variety of things in that arena. He's come back here and is on the faculty in the School of Computer Science. He and Don Marinelli started the Entertainment Technology Center. And his latest coup is that he's been developing for some time a system called Alice, which allows anyone, kids love it, to build little virtual worlds with which they can tell stories. And the latest coup is a collaboration in which the next version of Alice will incorporate the characters from The Sims. So Randy's going to take us on a quick tour of all of the 50 years of computer science at Carnegie Mellon, or at least the photogenic parts, Randy being a photogenic kind of person. And now it's Randy's turn.
Thank you. Thank you. We're going to be on a whirlwind tour. If you're familiar with the Reduced Shakespeare Company, that's going to be what it's like. 50 years of computer science innovation. So let's talk first about what's going to be happening here. There's going to be a new building. I think most of you are aware of it. It's going to be the Gates building. I thought we'd just get all the Gates building jokes out of the way. Okay, so a lot of the money's coming from Bill Gates. It's a new building, so yes, every office will have a window. That's not funny enough? That's funny. Okay, good. There will be light food service, but there will be no apples. The jokes are not going to get better, I'll just warn you now. And don't worry, the integral history of architecture at Carnegie Mellon will be preserved, because the new Gates building, shown here in a photomontage model, will maintain the high standards we grew used to in Wien Hall. So 50 years of computer science innovation. So Randy Bryant came to me and said, well, we asked some famous people and they were busy, so could you give this talk? And I said, gee, this is a hard talk to do. I mean, let me think about this for a minute. 50 years of history, much of which I wasn't alive for, or certainly sentient or aware of, to a room full of people who know it better than I do. And in particular, it's a room full of academics, all of whom are pretty much only here to answer the question, did my stuff make it in? So I said, yeah, that sounds like a great idea. So I was very excited about that. So here are the ground rules. First off, this talk is neither comprehensive nor representative. Sorry, okay? There will be some research from the last 50 years that will not be mentioned tonight. It is biased, as Mary said, towards good visuals or good stories. So this is not an attempt to necessarily call, I'm not here as a report card for what was the best research. And we particularly decided that we were going to go for narrative threads. So not sort of a particular isolated research result, but stuff that we've been doing for a long time here, where there's a chain of stuff that captures the flavor. I also told Randy I'd like to put in stuff from the culture of the last 50 years, and he enthusiastically agreed. And before I get started, I wanted to thank Deborah Harris and Joanna and Brian, and of course Mary Shaw, who worked very hard to help me put this together for your benefit. So I'd also like to tell you the process a little bit. Randy said, the boring way to do this is chronological, in 1956, then in 1957, and I could see you all like about 1982, you'd be like, all right, because I know that look because I see it in my lectures all the time with the undergrads. So he said, how about if we start with the fact that you've got Simon and Newell and Perlis, and this is actually a shot of Randy's whiteboard, and sort of the paths that flowed out from them, because it all starts with them. And that seemed like a good idea, and in further iterations, it got more and more complicated. And I wanted to thank Randy because he was very helpful in putting this together. And he, in fact, does have a database of the research highlights of the last 50 years, and we pulled on that. So anyone who feels that they should have had their stuff in, Randy Bryant would be the guy to talk to. So, all right, and I'm going to be moving fast. So, our origins. come back with me in time to the 1950s. All right? Here we are on Carnegie Mellon's campus. The fence is still there. Skibo was still there. We all have fond memories. Oh, I'm sorry. I apologize. It's the 60s. It's going to be a long evening. All right. All righty. You're out with your sweetie, but the hell with that. There's a computer now. All right? The IBM 650 arrives in 1956, and the world changes forever, starting with that moment. It goes into the basement of GSAA. I just love these cars. All right? That's just an amazing shot. And later on, another very important piece of hardware is the Bendix G20, which arrived a little bit later. And then there was the G21 that was done by Jesse Quasi. Is Jesse here? Okay. Thought he was here earlier this morning. Okay. So these were some of the seminal early machines that the very first computer scientists cut their teeth on. But I want to stress that the origins are not hardware. All right? I mean, this may be about computer science, but the important part are the people. And we were blessed with incredible people as our origins. Alan Perlis, all right? And I thought with each of these, we don't have very good video necessarily, but I thought it was very important for you all to, at least for those of you, particularly the younger people, to get a little bit of a sense of these three giants.
Well, I've enjoyed these two lectures. It's been a pleasure to be back. I'm sorry I haven't had time to meet all of the first-year students who I had the privilege of writing letters of acceptance for, etc. And I wish you all good luck and whatnot for Navy. It's a great place.
Alan Newell. Listen carefully how he describes his age at the beginning of this.
When you get to be 2 to the 6 years, you can't find any good science to talk about, so you got to talk about the past. But that's not true, it turns out. And I could have talked to you about SOAR, all right? So let's start.
And of course, Herb Simon, all right, who, lest we forget, did start as an economist and is the only computer scientist I know of with a Nobel Prize, which he won for economics.
I watched this 29. Anybody have another time? Add them all up and average them. 27? It's a good rule in science that when a new field opens up, you better be there firstest with the mostest. It's usually the people who get there early who are able to maintain a position on the forefront of that science.
I'm very fortunate that I was able to meet all of these men, and they really, truly were giants. You didn't have to spend very long with any of these men to realize that they were playing the game at a very different level. It's very hard for most organizations to say sort of what's our defining moment. There is this letter to science, and I'm going to mildly paraphrase it, but it's the study of computers and the phenomena that surround them, which is that broad, inclusive definition of computing and computer science that I believe has served us very, very well throughout the years since then. So let's start with our first thread. One of the things that fascinated our founders and continues to fascinate us to today is problem solving, symbolic manipulation, and of course, chess, the ultimate example of that. So there's been work in symbolic processing and logic processing for a long time. I don't think for most of the people in this room I have to spend much time talking about the early AI work. I love the R1 expert system. The name for that was derived from the old joke about I didn't used to be able to spell engineer and now I R1. So that thread has continued throughout the ages, and we can talk about whether it's model checking or symbolic processing, but the whole idea of using computers to do forms of reasoning, which of course have become much more complex, is a thread that has gone all the way through our history. But the problem that fascinated everybody from the beginning was chess. It was the de facto measure of intelligence. If one person could beat another person at chess, that was somehow a well-defined measure of, for that particular task, they were somehow smarter or more intelligent at playing chess. So it was fascinating to everyone from the very beginning, and chess playing was something that was worked on very hard here. So in 1985, Hans Berliner and Karl Ebling did high tech. I love Karl Ebling's thesis title, which was All the Right Moves. And then, of course, deep thought was done here. CB, who is one of the more colorful characters in the departmental history, he was very interesting because he sort of said, I don't like chess. I'm not a chess player. This is, to me, is just sort of like a really cool engineering problem. and he just took out the big engineering hammer, and he got this database of 40,000 grandmaster moves, and he beat it to death from an engineer's perspective and made tremendous progress. This, of course, eventually led to Deep Blue, which was the first computer done at it was the first computer, it was done at IBM, and it was the first computer to beat a reigning world chess champion human. This tradition of moving from sort of a concrete, finite, logical way of attacking things to sort of a more of a statistical model, we now see continuing on the thread of two of the institutes here, the LTI and the MLD, the Machine Learning Department, which just recently got renamed, was called. And we used to try to do everything like humans do it, and now we figured out that there are better ways than what humans do it if you're a computer. And these newer units are led by Jaime Carbonell and Tom Mitchell, and these are two of the best examples of reasonable people I know. Well, what do I mean by reasonable people? Well, one of the things about this department, or this culture, because there wasn't a department at the very beginning, and then there was a school, et cetera, is that we've always been good folk. Now, I'm not saying that at other universities people aren't good folk, but I think the jerk ratio is a lot higher at almost every other university I've ever been, right? The taking oneself too seriously, pompous, that really doesn't fly around here. And there are a lot of reasons for that. We've always been a community of shared resources and communal funding. Yes, it was a lot easier to implement that when, ARPA would drive by with a Brinks truck and shovel money out the back. Okay, that made it pretty easy to be a socialist, but we've worked very hard to that. It would have been very easy to give that up when the money became harder to get, but we have hung on to socialism, and it has served us well. Communal funding, allowing people to work with who they should work with and trying to find a way to make the money work out is very, very atypical. People who've only been at Carnegie Mellon are shocked when they go to other universities and find out that it really is sort of, every man or woman for himself. And Alan Newell, very early on, articulated a principle that we all live by called the reasonable person principle, which says we expect people to behave reasonably, and we don't go around making lots of rules trying to constrain people's behavior because that's very inefficient. If people are behaving reasonably, we don't need lots of rules and control. I didn't really understand what he meant by that until I taught at a state university, where it seemed like there were a limitless number of rules that all started with, since we presume that any state employee, such as a faculty member, will steal pencils, right? And this is one of my favorite sort of little capsule descriptions of what Carnegie Mellon is like. This is Raj Reddy, and I always like to visit Raj because I always feel better when I leave his office, which I think is part of his hypnotic spell. I usually do end up getting the half Raj or the full Raj, and getting asked to do something, but I always feel good. But what I love is if you look, he's always got candy on that table, and look at what he keeps it in. There's just a lot of very take myself seriously academics who would have ordered a special cabinet to put that in, but it just turns out it holds just the right amount of Hershey's Kisses. So, let's talk about hardware. One of the most famous projects done here was, and all these dates are a little bit squishy because it's not like you did a project in 1 year, but this is to sort of put them on the map, on the timeline. C.MMP in 1972. 16 PDP-11s with a 16 by 16 crossbar to memory. The name that is most often associated with this is Bill Wolfe, but obviously there was a large cast of characters. I was told that at one point there were 19 PhD students working on this project, and the Hydra operating system was written for it. And I believe we have a piece of the prototype for C.MMP here, brought to us by Dan Swaruk. So a piece of history. So it certainly makes me appreciate how much easier things were by the time I became a computer scientist. I think we oftentimes, us young bucks, tend to forget how much work it was to get anything to work. And C.MMP was an incredibly ambitious project to show that you could do something with multiprocessors. CM star, the CM, in case you were wondering, stands for computer module, came a few years later. And the crossbar is a great idea, but it doesn't really scale if you think about it. If you want to go from 16 processors and 16 memory units up to 32 and 32, it becomes very unwieldy. And you very quickly realize you better have nonlinear access to memory, and that's the only way to get scalability. And the operating system that ran on this was Star OS, which was done by Anita Jones. Just a point of personal privilege, I got my PhD here in '88. I then went and spent 6 years in a state institution I taught at the University of Virginia, and I went there because Bill and Anita were there. And I can't avoid Carnegie Mellon in my life. I go for a summer internship at Xerox PARC. Well, you can't swing a dead cat without hitting CMU people there. I go to Adobe for a summer. Chuck Geschke, right? Another incredible CMU person. I go and spend time at the University of Virginia, and I really appreciated the mentoring I got from them and the CMU style that stays in the people when they leave CMU, which is really one of the special things about the people from this place. Hardware continues. Systolic arrays embodied in the warp and iWarp projects done by Kung. And the most modern thing, now this is really lunatic fringe. Imagine computational modules that are at nanoscale but can rearrange themselves. So this is a simulation of how it might look if you had enough of these things that matter could rearrange. So these all go down to the floor, and you get kind of a puddle. And then they grow back up. Now, of course, this is just a simulation. But the interesting challenges from the Claytronics project are that the things that are hard aren't what you think are hard. Right? It turns out that the things being able to support the weight and all that aren't the biggest challenge. The biggest challenge is that if you can make this work, it's going to heat itself very, very hot. So avoiding melting is their major research challenge. Okay, let's talk about algorithms. We sort of early on rejected the notion that computer science was just the study of algorithms, but I don't think anybody would ever say that algorithms aren't a part of computer science. One of the things about algorithmic research in this department is that when you can study anything, there's a temptation to go off and study the irrelevant things. And the algorithm work that's been done here has always had a very strong flavor of pick the important problem. Because if you're a really smart person or you can solve any problem you want, pick one that people care about. All right? Back in '76, linear triangulation, which is still sown in the seeds of all the triangulation work that goes on in every simulation that you see that involves cutting up geometric stuff into smaller pieces so you can compute with it. Speaking of John Bentley in 1986, he began a series of books called Programming Pearls. John Bentley, gosh. One could do a whole talk on John Bentley stories, so I will refrain from going too far into that, but a few that are worth it. There was the day that John Bentley was skateboarding to work, and there was a recently imposed campus policy that you could not ride a skateboard to work. And so, of course, campus police grabbed him off his skateboard and said, "We demand to see your student ID." And he said, "I don't have one." And they were really excited because they thought they actually had, like, an infidel and they could lock him up. And so as they were starting to march him off to the Hoosgow, he apparently turned to them and said, "Will a faculty ID do?" This is the same man that would take a basketball out in the hallway when it was crowded with academics, roll it down the thing and say, "I'm bowling for scholars." And who could forget when Bentley would take the remote control car and fill it with firecrackers and drive it around the corner into Merrick First's office? I certainly won't ever forget that. So, Bentley is one of the many characters that have gone through this place. And this is a place that has always encouraged sort of nutty behavior, but in a mostly healthy way. In 1986, the initial algorithms for backpropagation in neural networks. Huge, huge result. And GraphPlan, which is one of those unusual projects because you don't normally have sort of the hardcore theory people and the AI people working together. And this was a seminal example of that, and this is now used in most planners. And some of the most recent stuff, Jessica might say, that's not algorithmic work, that's graphics. I don't know. I think when you're doing that much calculation, it's algorithm work. And here's a very large number of plastic chairs, all falling and deforming. This just goes on. At a certain point, you get the sense that Doug is just doing this because he can. Yep, he's not done yet. And of course, to be mildly technical about this, if you look carefully, these are not just falling and colliding, these are deforming. They're behaving like plastic garden chairs. And if you look closely, it's really quite stunning that he's getting away with this much calculation. And that was presented at last year's SIGGRAPH. This does go on, doesn't it? Okay. All right, and CAPTCHA. This is a really fascinating line of work. I mean, the Turing test says, can you tell if it's a human being or a computer? Well, the inverse question is really kind of interesting. Can a computer tell if you're a human or a computer? Most of you have probably had to pass a CAPTCHA challenge if you wanted to get an email account at Hotmail or one of these other, sign up for free, you don't have to give us any resources, you get an email account. Because, of course, the danger there is that spammers will write bots and harvest thousands of email addresses so that they can send spam and then close out the email account. Well, that doesn't work if you have to answer questions like, what characters do you see here? And the really subtle part of this research is being able to automatically generate the challenges that a computer can't automatically answer. And it's really a marvelous piece of work. So, computer vision. We've worked on computer vision for a long time. I'm just going to show you my personal favorite example. There was a 3D instant replay at the Super Bowl a number of years ago. This started out as Takeo Kanadi's virtualized reality. And here's how it played out at CBS in the pregame show.
Here at the Super Bowl, 30 robotic cameras have been mounted on the scoreboard and all along the upper deck at intervals of 7 degrees. Each camera feeds into one of the 30 specially designed digital recording devices. The images are then computer calibrated to instantaneously show any spot on the playing field from all angles within the camera's 220-degree range.
So there's a lot to be said for playing for high stakes, and doing a novel instant replay for the Super Bowl beats all heck out of, oh, we got it to work in the lab last night. So let's talk about speech and media. Obviously, speech input, voice recognition has been something we've done for a very long time here. Without going into great detail, here's sort of the lineage. We have, since this was done in the Robotics Institute, which has always had, shall we say, slightly more attention to archiving their material than the rest of the school, which is to say more than 0, which you discover when you put together a talk like this. And there's some very lovely footage here that, if nothing else, really captures the essence of various points in time. So.
Colorless paper packages crackle loudly.
Colorless yellow ideas flee furiously.
Alan Newell.
Sweet roses, dangerously young colorless.
Ben burada ne yaptığımı bilmiyorum.
At Carnegie Mellon University, we have been working towards a system for speaking to computers. In this film, we will try to show the problems that arise in getting a computer to understand speech.
Tell me all about China.
When an utterance is input through the computer, several pre-processing steps are taken to prepare the data for recognition.
Tell me about war. Tell me about Nixon.
Since the end of the project, the system has been further improved and at present runs an order of magnitude faster.
He looks so young. And then there's the question of, well, if you can understand what people are saying, what are the coolest things you could do? Now, obviously, transcription is one of the obvious applications. But here's a neat one. If you can listen to what people are saying, maybe you can help teach them to read.
At Carnegie Mellon University, Project Listen is taking a novel approach to the problem of illiteracy. We have developed a prototype automated reading coach that listens to a child read aloud and helps when needed. The coach provides a combination of reading and listening, in which the child reads whenever possible and the coach helps whenever necessary. A bit like training wheels on a bicycle.
And most recently, there's sort of this lunatic fringe stuff that Alec Weibel and company have been doing. So watch a little bit carefully here.
The first one is a so-called lecture translation, open domain simultaneous translation. You see here on the left screen, it's already working as I'm giving this lecture. Translation goggles. You may want to see the translation of the lecture. Translation is being synthesized, and the output translation can be delivered just to one person, and everybody is not disturbed by the sound that comes out of it.
So that's a directional speaker. She's basically beaming a column of sound. And it's one of those technologies where until you actually hear it with your own ears, you don't believe it. And then for about a week, you still don't believe it, and you go back and listen to it again. Alex is certainly willing to throw everything at the problem. The latest thing he's been doing is a demonstration where there are sensors on the skin, and he can translate what you're saying even if you don't make any noise, which is pretty impressive. So, of course, more goes on here than just research. This has always been a place that is a community of people that have had a variety of interests. We found different ways to deal with the Pittsburgh winters. Pretty good race. I think anybody who's willing to run that hard, that fast deserves to have their stuff shown on this slide. And who could forget the cheese co-op? Back in the day, people would go down to the Strip District and they would order up to a ton of cheese. And of course, being computer scientists, you've got dozens of people ordering a ton of cheese, and you can't buy the cheese in any increment you want because it comes in wheels of certain weights. And how do you possibly figure out how to divvy this up and maximize everybody's demand for how many pounds they wanted? Well, you write a computer program. So we actually have the source code from the Cheese Co-op computer program. And I don't know if you can read that there, but it says, step 1 until numb cheeses do. This really smells of thesis avoidance, doesn't it? But this was a huge institution within the department. We actually still have checks. We dug up the old box of the Cheese Co-op stuff. We still have their checkbook. And amazingly, there's still money in the cash drawer. So if there are any members of the Cheese Co-op, please see me after the talk and we'll divvy it up. Okay. The Guide to Living in Pittsburgh. When I first got here, I just thought this was just incredible. Somebody had gone to the trouble to make a book to tell me about this new city that I had just become a citizen of. I thought, wow, they really don't want to work on their dissertation. I mean, this is elevating procrastination to a world-class level, which of course is an indication that Brian Reed was probably involved. So, and I love the opening page, being an account of how 2 graduate students determined to study at a great university came to the city expecting the worst and never found it. Right? Which I think really is, they should put that on a banner as you drive into Pittsburgh. Right? We're sorry to disappoint you, but it doesn't suck to live here. It's actually a great place. That sign works better in June than December. But, and there have been continued updates. There was a period of time when this was published by Carnegie Mellon, and then apparently because they said things in here like, you should not go to Mellon Bank because they will screw you over. For some reason that apparently didn't sit well with Mellon Bank, who came and talked to the president of the university, who in the great spirit of academic freedom suggested to the students they should take that part out. And in a greater spirit of academic freedom, the students formed a nonprofit and took the book out of the university, which it was exactly the right answer. And the book is still available for purchase now. Yes, you can still buy this? I believe so. Okay, emoticons. Yes, you have to turn your head to the left. These were invented here. They were invented by Scott Fahlman. This is the original email. I propose that the following character sequence for joke markers. Read it sideways actually is probably more economical to mark things that are not jokes given current trends. If you type in Scott Fahlman to the web search engine of your choice, you'll get to his page. He has the whole thread that led up to this. It is positively hysterical. And again, an indication that some people were trying to avoid working. So let's get back to a thread of the research work that was done here. Software, operating systems, applications. This has always been a place that has taken great pride in building real systems, not little toy things, but big, real, aggressive projects. Brian Reed in 1976 did a system called Scribe. And the key insight in Scribe was that you really don't want to be specifying where on the page things go. Now, this whole approach was later subsumed by WYSIWYG, what you see is what you get. But back in the day, you had to type in something that described how to lay things out. And Brian said, you don't want to say, put this 2 inches from the left margin. You want to say, this is an indented bullet point. And then Scribe will figure out how that should look. And the great part about this is there was something called Scribe Mellow. Because we compulsive people, which would be pretty much all of us, with other systems, we'd spend hours getting the damn thing to go over that last 1/4 inch. But with Scribe, that was so hard to do, and in many cases impossible, you just go, that's good enough. One of the early hypertext systems was called Zog. It ran on the PERC, certainly one of my favorite machines. God, I miss having a PERC. And it was deployed on the USS Carl Vinson. So we don't just do hypertext in the lab, we do it on ocean-faring vessels. In one of my first experiences here, there was an immigration course, and the speaker was talking about the length of the Ethernet and how long it had to run. And it was just this arbitrary distance he kept referring to. And somebody put their hand up and said, excuse me, why is that distance so important? And he just said, oh, because it's the length of an aircraft carrier. And he just kept on going. And I was like, okay. The Andrew Project. I personally think the Andrew Project is one of those things that does not get enough credit because what they built there has just become sort of an assumed part of the fabric of using computers to communicate with other people. But if you think about what they accomplished at the time they did it, everybody in that time frame was saying, every student's going to have a computer. They're all going to have a PC. And they're all going to have a computer on their desk, and they're going to use it for work. And people in the Andrew Project, Jim Morris headed this up at the Information Technology Center, and they said, gee, everybody gets a node on a network. And the crucial thing about these things is they're connected together. Satya and other people, the Andrew file system, it's all about the information and linking the people together. It's not a bunch of islands, it's a bunch of nodes that are connected together. The whole idea of multimedia mail, which we just kind of take for granted, that you can attach a JPEG or a movie or a running application. I will never forget the first time I saw somebody send a piece of mail through Andrew, and they mailed a running application, a runnable application, which was a piano. And it would you'd bring it up in your email, and you have this little piano, and you could clink on it and make little notes come and play. And I just thought, wow, that's just incredible. And when you think about it, being able to mail an application opens up the whole possibility of viruses. So we really have Jim Morris to thank for that. The thing that Jim Morris did that I thought was one of those really strong moments of management was at the time all the developers had big, powerful machines, which meant they had 2 megabytes of main memory. And all the campus users had 1 megabyte of main memory. And the people working on the Andrew system could not understand why everybody was talking about how slow their machines were. Well, the 1 megabyte machines were just paging all day long. And Jim Morris finally put out an edict that he was going to reduce the memory in all the developers' machines down to 1 megabyte, because if they were feeling the pain, they would tighten up the code. And that actually worked, except for Nathaniel Bornstein, who snuck the other megabyte back in. The Mach operating system. It was a successor to the Accent operating system that was done here, which was PERC-based. It was a microkernel-based system. And I just can't get over the tremendous irony. Rick Rashid is here, and he's head of Microsoft Research, and he works for the Microsoft Corporation, and his operating system runs the Mac. That's so cool, right? It's also a good story about stuff that is done that is really good finds a path to get out there. I mean, I don't think anybody on the Mach project would have ever imagined in a million years that it would go through the Next Corporation and into the Apple Corporation, and that would be the path by which Mach would get huge numbers of users. You just can't anticipate how this stuff is going to play out. Another project, Tabs and Camelot. distributed transactions. So instead of having a big machine somewhere that calculated when checking balances would go up and down, these could be done on smaller, much more distributed machines. Shown in red there is, Mary was actually my first advisor. I told somebody that once and they said, first advisor. Is that like first wife? Yeah. One of the great things about the culture here is that people can change advisors, and it's a zero overhead operation. So I learned a great deal from Mary. I learned a great deal from Al. I actually even learned some computer science from him. But the most important things I learned from Al were how to treat other people, how to run an organized research group, how to coordinate schedules, how to get the mechanics of a research group going. And I'm forever grateful for that because I've used it every day of my life. And a more recent software system would be Lycos, done by Michael Fuzzy Malden, the first web crawler and search engine. Now, there's a story here. Again, it has to do with thesis avoidance. Did anybody here ever play the game Rogue? Or am I dating myself? Okay, good. There's some other old people out there. Good. This was a highly addictive game, and it ran on ASCII terminals. It did not need whizzy 3D graphics. It was just addictive because you could just never get to level 26, and you just kept trying. And Michael was very aggressive about this. He played a lot of Rogue, and he finally said, damn it, I'm going to let the computer play Rogue. So he wrote a program that would parse the output to the 24x80 character screen, figure out what was going on, do all kinds of AI, and play the game. Now, it didn't play as well as an expert human, but it was very patient and tireless. And he figured out that, the way his machine was playing, it would probably take him till the heat death of the sun for it to win. But he had observed there was more than one computer in the world. And so he farmed this out and said on a volunteer basis, anybody who wants to can run Rogomatic on their machine at night, and if we all pitch in, we can beat the game. And he did it, and it worked. One day, he got this piece of email back from the system, and it said, we got to level 26, here's the amulet. And this was like a cause of great celebration. And you could say, well, this is just a grad student screwing around. And at some universities, they would say, that's a total waste of time. Well, isn't it amazing that when the web comes along, the first thing Fuzzy Malden thinks of is, oh, well, I should be just crawling out there and harvesting all this stuff because it's all just one big distributed system. All right? Letting people screw around is very valuable, particularly if they're as smart as he is. So there's a room in the building Newell Simon Hall named after him. I would like to publicly say I think we missed a tremendous naming opportunity. I think this should have been called the Fuzzatorium. So, and of course, software engineering has been a thread here. There's been a lot of activity in this area. The capability maturity model is something that if you travel to Southeast Asia, and you say, I'm from Carnegie Mellon, they're like, You say, well, we have this thing called the SCI. I say, oh, we know all about the SCI and the capability maturity model. And it's kind of interesting. The Search Center has been placed here, which we read about every day, bad things that happen on the internet. And of course, ISRI, which is the Institute for the Study of Raj's Interests. So, robotics. So now we get to the good, flashy video stuff. All right. Robotics goes way back here. We've always taken a very, very rich approach to doing robotics. The first direct drive robot arm was done here by Takeo Kanade. Let's see how that looks.
The world's first direct drive arm prototype, the CMU DD Arm 1, was constructed in 1981. 4 years later, a second version with a full 6 degrees of freedom was produced. Using these prototypes, researchers at the Institute have been working on real-time model-based control for fast, precise, and dexterous motions.
The whole area of field robotics, Red Whittaker, I think is the name most associated with that, but there are many, many other people. We are interested in going to the places that are the hardest places to go to. NavLab, we've had decades of research here on getting vehicles to drive themselves. One of my personal favorites is the hopping robots that was done by Mark Raybert and Ben Brown and Jessica Hodgins. There's just something about these robots when they hop that is just so bloody anthropomorphic. And the ultimate piece of showwomanship was something that Jessica did. Okay, torch on. a two-legged hopping robot that just looks like it's skipping. It didn't look scared at all. Building robots that go into broken nuclear reactors, again, is moving you a little bit out of that toy problem space, right? Synchronized navigation to track the sun and harvest its energy, because when you go to other planets, you're going to have to do that. And Dante, going down into volcanoes. It's not really that fast.
Dante 2, an 8-legged walking machine, is shown here during field trials with its action sped up. Named for a 14th century Italian poet, this 20th century robot has been designed to withstand and report on its journey to the floor of a volcano.
Grace, the robot that solved the standing challenge of the extremely representative and important real-world problem of registering itself at an academic conference. Okay. I mean, an important challenge, but boy, that was self-referential. But she did, and then gave a talk about herself at the conference. So, and of course, RoboCup Soccer, Manuela Veloso and her students have been working on this for a long, long time with absolutely stellar results. They've won RoboCup a number of times, which is one of the few times that there's sort of this fair competition kind of bar for researchers to have to sort of get into the gladiator pit against each other, metaphorically. It's very important to remember that a lot of the projects that are done here have the flavor of this kind of picture, right? A whole lot of people. Right? There was mentioned during one of the Titan sessions that I think it was in reference to Bill Wolfe about getting different kinds of people together and getting critical mass to attack problems you couldn't solve as individuals. And this is something this place has just always done well. And of course, the Red Team and the DARPA Grand Challenge. Again, there's another stunning example of a very large crew of people going after a hideously difficult problem. Spinner is one of the most recent things being done. This is down at NREC, and this is just so macho, I have to show it. So that's a 36-inch vertical step. Tanks don't do well with that challenge. And that's 43 inches. But wait, there's more. Now, the next part is a simulation of what this is claimed to be able to do in the future. Because if you're probably looking at that, you're saying, that's great, but boy, that thing is going to turtle sooner or later. It's going to go over on its back. Well, if it does, no problem. What's not to love? So, let's talk about Black Friday. So, those of you who were here earlier heard Joe Trabb tell the story of where the name came from. There's always been a sort of a DRC, Departmental Review Committee, but there was this idea of formalizing the review so that all of the faculty would jointly discuss the students at a periodic interval once a semester. And this was really done not as a punitive thing, as I'm given to understand it, but instead sort of to make sure that students didn't get lost, fall between the cracks. You know, when people say, I haven't seen the student for a couple of years, have you? That's a bad sign. So, so the story is told that you and your wife were watching this B-grade horror flick. Is that actually the poster from it? Does it look familiar at all? Black Friday is one of those interesting things because I first came here as a student, of course, and Black Friday was this really scary thing. Like the faculty would all lock themselves in a conference room all day long, and every now and then we would hear like really loud laughter. And you almost expected like every now and then a carcass would get thrown out or something. It was really this sort of, they're talking about us, and some people have to leave when they're done. And there are different ways that you deal with this as a student. You have to break the tension somehow. So one year the students made up the Black Friday mug, and they gave them to the faculty as they went into the meeting, kind of as like a peace offering, right? This happened not too long after I got here, and I was like, this is really weird. You know, this is like, what's next? Virgins to the volcano gods, right? But what was really worrisome about this mug was on the back. There was a listing of how many people had gotten kicked out every year. And you can probably see the high watermark was 8. And now I'm not going to say which faculty member it was, Mary Shaw, but it is rumored that one of the faculty members, upon assessing the numbers, dead-eyed the student who had handed her the gift and said, "Raise the stein for 9." But did you ever wonder, faculty members, what the students do during Black Friday? I mean, besides sitting in their offices cowering, right? The students actually get together and have sort of this very bizarre, macabre TG, which is what we call parties around here. And we have contests. And one year we had a contest to impersonate faculty members. And I actually won this T-shirt, which of course very self-referentially says, imitate the faculty on Black Friday, for my impersonation of Jaime Carbonell. So I was very pleased to have won this T-shirt. Impersonating Jaime Carbonell is like shooting fish in a barrel with a bazooka, right? But more seriously about Black Friday, now that I went away for a number of years, taught at the University of Virginia, then I came back here in the faculty, and when you're in the room for Black Friday as a faculty member, it is completely different than, so this is like the part where like David Copperfield gives away the magic secrets, right? What really goes on in that room is not, oh, this student's an idiot, let's kick him out. I mean, well, okay, maybe, but no, that's not what goes on. What goes on is this student in trouble? Are they making progress? If not, why not? I've seen faculty members really have their feet held to the fire for were they advising the student properly? And what I think is the best dynamic of Black Friday is it's a tremendous forum for the intellectual efforts of a large number of people to all focus on one person and their needs when it can help them get through a very rigorous, arduous process. And the dynamic I particularly like is when more senior faculty members are able to pass on advising tips and techniques to the more junior faculty members, which just works out great for everybody, because the junior faculty member gets to leverage the expertise, the student gets the help, and the senior faculty member gets to, well, feel important. So, right? Human-computer interaction, one of the more recently named areas, although I think the idea of humans interacting with computers has been with us since the very beginning. We just didn't have capability to do much in the early days. The term was actually coined in Stu Card's dissertation here. And there were a lot of attempts following on in the earlier work to do symbolic processing and modeling to do modeling work. The GOMS and SOARS projects were attempts to derive models that would give us predictive power of what would happen when you had a new user interface that was going to be used. Some of the most recent and exciting work are things like the cognitive tutor work, where they can help students learn very difficult topics like geometry, like algebra, by developing a model of the student's ability to learn and their current cognitive state, and then paste the material and alternate for the student's specific needs. And this is the kind of stuff that I think we're going to see more and more of in the next 10 or 20 years, where we get enough leg up about learning how people learn that we can finally hold on to or take advantage of the real promise of computers for individualized instruction. And that's very exciting to anybody who's a teacher. Pearl, as part of the NurseBot project, this is an attempt to bring care to the elderly or to other people through embodied robots. This is the kind of thing where if you look at the demographics for the population, either real nurses are going to make a lot more money, or we're going to have robots coming in and doing part of the job. The real research question here centers around, if you've got a robot providing help to an elderly person, what's going to fly and what's not going to fly there, right? Because providing help is not the same as having it accepted. So knowing in what ways a human will and won't interact with a robot is absolutely crucial. And then there's the wearable computer work. There's been a long lineage of work done here by Dan and Asim, who I call Dan and Asim because attempting to pronounce those last two names is beyond my powers. And this work has been going on for forever, and it has that, again, Carnegie Mellon real-world flavor to it. So certainly some of this goes into the military, but some of it goes into General Motors. It goes into places where there are real needs for people to be wearing computation and doing things more productively, faster, fewer error rates, or lower error rates. Here's an example of a soldier using this thing in the field in Bosnia, and it is a translation system used by NATO troops at checkpoints where they can translate from English to Serbo-Croatian. And it's kind of interesting because the soldier will say something like, "Don't come any closer!" And the thing will, do the equivalent in Serbo-Croatian of, "Don't come any closer." So you lose a little bit of intonation. But the fact that it is really used by NATO troops is very impressive to me. I asked Dan Swarwick in a candid moment. It was right after the MIT Media Lab had done their wearable computer fashion show. So they had a bunch of anorexic models wearing mock-ups, some of which didn't actually have any computing stuff in them. Some of them worked, but some of them didn't. And I was looking at this and I was saying, well, that's one way to do wearable computers, and the design aspect is interesting. But, and I said to Dan, does it kind of hack you off? Because you're doing all this real detail-oriented stuff. And he said, they're turning the planes around faster in Afghanistan using my stuff. I sleep at night. And I like that, okay? I mean, I'm solving a real problem that somebody needs solved. And that's the Carnegie Mellon way. So let's talk for a moment about education. I've talked at length about research, but at the end of the day, the most important thing this place produces is people. That is our number one output, always has been and always will be. Well, I always like to tell people that getting your PhD at a place like this is like becoming a Jedi Knight. We can't train all that many of them. We really don't do it very efficiently, and it's not a pretty process, right? I mean, I think the scene from the movie that really captures it is this one, right? I mean, this really embodies the PhD process for me. You're in a damn swamp for forever, and there's some annoying bastard just riding your back the whole time. And just about the time you're ready to leave, you realize that you've actually been carrying your advisor. So, and at the end of it, you get to be called doctor. And my mom was always great about that. When I got my PhD, she started introducing me to people. Oh, and this is my son. He's a doctor, but not the kind that helps people. The immigration course. This was something that really distinguished this place. To the best that I have been able to unearth the history, way back in the day, we were a more traditional department with 2 years of coursework, and then you really got your feet wet with research. There was a bit of a palace revolt by the students who said, we want to be doing research from the beginning, and these courses just remind us of more time in undergrad. And so there was a major change to a syllabus-based, think English reading system. There will be a test, but it's up to you to prepare for it. There were courses, but they were voluntary. And the problem with that is that one of the things that courses do that are mandatory for students at the beginning of a PhD program is it's a cultural, for lack of a better term, assimilation. And you still need to perform that. So in what I think was an act of sheer brilliance, there was the creation of an immigration course, which originally lasted probably 6 or more weeks. You saw all the research going on in the department. You learned everything. You all went to 5409 or whatever the room du jour was, and you stayed in there all day long for your first couple of weeks, and boy, you bonded with each other, much like hostages. So, of course, the more things stay the same, the more they change and cycle back and forth, and in the 1990s, we've gone back to more of a course-heavy model. There is still an immigration course, so one could argue that we're having both of those. And we now really go to courses. So for those of you who were here a while ago and used to have qualifier exams, it's really much more about passing more traditional courses in your first 2 years. I mean, part of me says I really miss that. I mean, I remember the qualifiers, And boy, they were a bear. But there was something about that thing staring you in the eye and, saying, can you get over this bar? That was just different than a course. I will never forget sort of, again, my mother helping me keep perspective on things. One of the many times I was in the midst of failing the theory qualifier, my mom was talking with me and I was telling her how hard graduate school was, this terrible theory qualifier, and how awful it was. And she just leaned over and she put her hand on my arm and she said, I know exactly how you feel. And just remember that when your father was your age, he was fighting the Germans in World War II. So maybe the quals weren't so bad. Somewhere along the line, we broke free of the Mellon College of Science. There was a brief period of time where we were a freestanding department, and then we became the School of Computer Science. No one could tell that story without thanking Angel Jordan and the late Nico Haberman, who was taken from us way too young. And the work they did to create the infrastructure that now allows us to pretty much do whatever we want, which is the great thing about being a school, right? Cannot be overstated. This was sort of the keys to the kingdom of really spreading out our already broad definition of what computer science was to sort of as wide as our arms could go, because now we were a school, and eventually we could have departments and institutes within the school, and it would all just become like one big, happy, or dysfunctional, take your pick, family, all right? But it gave us the ability to grow, which we wouldn't have had if we'd stayed under the dean of something else. Speaking of how much we've grown, here's some stats that people who have not been here in a while might find absolutely astounding. Right? These are all the different things that you can get a PhD in. There are almost 400 students enrolled in various PhD programs, and only 150 of them are in what you would say is the computer science PhD program, right, if you're talking about just that department. So the diversification by degree is just stunning. We've also really ramped up master's programs. So again, you can look at the large number of people that are now coming here and getting master's degrees. When I came here, if you told somebody you had a master's degree from Carnegie Mellon in computer science, that meant consolation prize. That meant you had survived long enough that they felt guilty kicking you out without a piece of paper, but you weren't going to get the PhD. So the fact that we have such a healthy and vibrant set of degree programs speaks well to what becoming a school allowed us to do. And my goodness, look at the undergraduates, right? And look at that combined SAT score. Ouch! It's hard to get in here, right? And that number could be higher. What's most stunning about that combined SATs number is that we've de-emphasized SATs. Jim Morris famously, sometime in the 80s, I was talking about how high the SAT score is, and he said, yeah, but that's because Carnegie Mellon will admit an idiot savant if they can score 800, right? And we've really moved away from that. We now are admitting people based on a lot of qualities, and it just so happens that scoring well on these standardized tests is coming along for the ride. The undergraduate program was a real sea change for this place. The faculty, truth be known, back in the 80s and before, weren't that interested in teaching the undergraduates. And that was what it was. And what is most interesting about that is that it expressed itself in strange ways. The institution wasn't that interested either. John Bentley famously won a teaching award, and the dean who gave him that award apparently told him, nice work, but don't let this happen again. You are trying to get tenure. All right? That's an ugly story, but that's the past. Let's talk about the present. What's most interesting is that the culture changed so much without any real incentives to the faculty. What happened was we decided to have an undergraduate program, and the undergraduates started to become very good very quickly. The faculty realized the undergraduates were very good, and the faculty put more energy into interacting with the undergraduates. The undergraduates got more excited, the word got out, better people applied. It just became the ultimate virtuous circle, so that within a very short period of time, things really took off here. And now we have what I think is very defensibly the best and most desirable undergraduate computer science program in the country or in the world. And one of the key sea changes was when the faculty realized that the undergraduates could actually be contributors to the research effort. Not just someone you had to teach as a chore, but someone who was, just like we had always viewed the PhD students, a peer who was just younger but could also participate, and was even cheaper than a PhD student. So the intro group, the set of faculty that we tasked with teaching and advising the heavy load in the first year, did such a spectacular job. And I was talking with Mark Stellick about this, and I was trying to sort of get him to distill their philosophy. And he said, well, we're enablers, not rule enforcers. At a lot of places, the advisors are there to enforce this set of rules to keep the students from doing things. And Mark said, we view our role as enabling them to get the best education they can. For a lot of them, that's going to mean risk-taking. We provide an environment where they can take a risk, and we're there to help catch them if they didn't make it to the other side across the chasm. But we want them to try those jumps, because if they play it safe, they're not going to get anywhere, and they're certainly not going to maximize their time here. And that's just a tremendous way to look at it. Enablers, not rule enforcers. And the other thing that Mark said is, at the end of the day, you can have all the brilliant curricula you want, and you can figure out the best teaching tools and processes, but what's going to determine whether or not undergraduates thrive at your university is whether or not they believe there is someone who cares about them. And both at the undergraduate and graduate level, we have the most stellar people in the world. Sharon Brooks, absolutely. Sharon Brooks and Mark Stellick are simply transcendent at what they do. And people like that are rare as hen's teeth. Let's talk a little bit about women. All right? This is another area where if you haven't been back to campus in a while and you start walking in the classrooms, you're going to notice that something has changed. All right? Way back when I was here, in the beginning, there were men and Mary Shaw, right? And then there was Anita Jones, but there were still not very many women. And then in the 1980s, this is not a joke. We counted. There were more Daves than women in the graduate program. That's bad. That's real bad. All right? So, as good academics, people looked at this and said, this is a problem to be solved. Let's treat it like a research problem. Right? Let's study it. Let's figure out what's going on. So Alan Fisher and Jane Margolis looked very hard at this. There's this lovely diagram, which you probably can't read up there, but it talks about how you change the culture, how you get more women interested. It's sort of a subset of the thing I talked about before with the virtuous cycle, because of course once you become a place that is encouraging for women, the numbers go up. That makes women more inclined to apply because they won't be a singularity in the class, and it can start to feed. There were two things that Carnegie Mellon did here that were absolutely crucial. The first thing is we started doing outreach to high school AP teachers to inform them about the kind of computer science we do here at Carnegie Mellon, its breadth and its excitement. The second thing was that, and this really, having delved into this a little bit, this really wasn't so much a gender thing as it was a priorities thing. We said, we would like to stop admitting people who are so narrow, who are so technically astute, but frankly, deep, hardcore nerds. Now, to give you an idea of how bad the hardcore nerd problem can be, and the total lack of social skills, are you aware that the first week of classes at Carnegie Mellon, we have to tape signs on the Wien Hall elevators on the 5th floor that say, let people out before you go in? That's a pretty low bar for social skills. One could argue that's a failure to understand simple physics. And we changed our admissions criteria and said, rather than worrying about how much hacking you've already done, how about if we look for, as Raj Reddy said, let's stop looking for drones and start looking for leaders. And if you start looking for leadership qualities, one of the things you're going to get for free is you're probably going to skew away from the hardcore hacker, which skews male. So that's one of the ways that by changing the kind of student you're looking for of either gender, you will get more women. High water mark in the year of 2000, 40% of our undergraduate entering class was female. I don't know if that's the highest percentage of any major computer science department ever, but it's certainly defensibly high and very, very wonderful. And it's the kind of thing where when you make the announcement to the incoming class that 40% are women, everybody goes crazy, and you're like, I wonder who's cheering louder. We now have women at SCS, which is very capably led by Lenore Blum, and I think that they have done a wonderful job of building a sense of community for the women in the School of Computer Science. They do a tremendous road show, if anybody saw it earlier today, and they have a tremendous set of outreach programs and a tremendous set of things that happen when people are here that, again, I personally would describe it as sort of countering the traditional nerd thing that you would expect. There's SCS Day, where you find out people in your community can juggle and sing and things like that, which I think is all healthy, because computer science is going to have to continue its path forward in a less nerdy way, because computer science is now part of the fabric of everybody's life. And, you know, ain't no glass ceilings here. Right? The chair of the department is female and very capable. I will predict from this stage that she'll be the next dean, just because I am very good at pattern classification and I've watched the previous deans and where they came from, but that's just a pattern matching thing. All right, so the next 50 years. Well, I don't know what's going to happen in the next 50 years. That's always the hard question. And we know that the Gates building is going to be a tremendous blessing. We've been cramped for space for a long time. And we know that that's going to give us room to breathe for like a week before we fill it. And then we're going back and demanding that the provost give us more space. Randy Bryant really deserves a lot of thanks because he has worked tirelessly on this. And Guy Blellock has had the awful job of being the guy in charge of the committee that deals with all of the things. And he has relentlessly fought for the things that matter. You know, all jokes about Windows aside, Windows in every office, thermostats in every office, the pragmatic things that we're all really going to pay for if they're not gotten right. Of course, all buildings create controversy, and certainly a building as large and as important and as tall as this one is going to generate controversy on a campus. Is it in the right place? Is it made of the right materials? What's its exterior? You know, fortunately, Jerry Cohen, our president, has a brilliant solution to the potential controversy. He has created the ultimate distraction. So now everyone who has to bitch about what's going to go up on our campus has literally a lightning rod to be drawn to. So with that, our tale of 50 years in very reduced form, there's no way to end a talk like this other than by asking you all to participate. So in your registration packets, you probably saw a blue piece of paper, okay? And this is an opportunity for you all to send in materials that will be compiled. And I would urge everybody to do this, because in preparing this talk, the one thing I learned is that this really is the blind man and the elephant. Everybody knows a little piece of the puzzle, but there's nobody who sees it all. And it's only through a communal effort that we can really get the joint memory of this place while that's still a solvable problem. So I would encourage all of you to do this. Fill it out. It's the blue sheet in your registration packet. And shortly there will be logistics and transportation down to a large gala at the NREC Center, where I'm sure I will get to talk to all of you about all the things that I got wrong or didn't mention you and your research. Thank you.